So today what we're going to be talking about is polynomial division. You'll notice the other day in our polynomial review, we really only talked about addition, subtraction, and multiplication. We left out division. But before we can talk about polynomial division, I would like to go back and just review for a moment long division in general. We've gotten so used to using our calculators now to do our computations for us, our arithmetic for us, that we do need to actually go back and review this whole thought process of long division. How would I take 2,738 and divide it by 23 if I didn't have my calculator handy to help me out? So let's review the process of long division. I do want to talk a couple of vocabulary words here, just in case everybody has forgotten this vocabulary. The number that you are dividing, the number that is being divided, that is called the dividend. So that is what is being divided. The number you are dividing by is called the divisor. All right, and then the answer that we're going to get, we call that our quotient. So just some vocabulary words here to make sure everybody is on the same page. And so when we're dividing with long division, you want to start with the divisor and you just want to work with the first couple of digits of the number. So the first step is actually going to be to divide. That's going to be the dividing part. So 27 divided by 23. How many times will 23 go into 27? One time. So after you do that division, your second step is then to take that number that you got and multiply it. So 1 times 23 is 23. After you multiply, that third step is then to subtract. So I need to do 27 minus 23, which is going to leave me with 4. Our fourth step is then to carry down the next digit. So I look up here, that means I need to bring down this 3. And then I need to repeat these steps over and over again until I've run out of things to carry down. So I'm going to start over again. Divide. 43 divided by 23. I think 23 will just go into 43 one time. 1 times 23 is again 23. Now we're on step 3, which is to subtract. 43 minus 23 is 20. And then I'm going to carry down the 8 and repeat again. 23 is going to go into 28. Well, it's not 10 times because that would be 230. Let's try 9. 9 times 23 does turn out to be 207. So then I'm going to subtract. 208 minus 207 is 1. And I have nothing else to carry down. Now, if we were getting decimal answers, we could then just put a decimal here and carry down a 0 and keep on trucking. But we don't want a decimal answer. We want an exact answer. And when you're giving an exact answer, you leave fractions. And if you have forgotten what we call this lovely little number down here that's left over when we have nothing else to carry down, we call it the remainder. All right? So I'm going to write my remainder as a fraction. And to write my remainder as a fraction, I take the remainder and I write it over the divisor. So I have 119 and 1/23 as my quotient. That would be my answer. So I have the quotient, the answer. We used our remainder and we put it in fraction form so that we have a nice exact answer. And this is the process of long division. Now the awesome thing about long division is that it is what we always use to divide. It will work for polynomials, even though we are going to be doing variables, and polynomials with lots of terms. These are the same steps. Long division is long division. It doesn't change for anybody. It's a process. Notice these individual steps, not terribly complicated. Divide, multiply, subtract. It's just a matter of you have to keep doing it. You do it over and over and over again. Can that turn into a long problem? Absolutely. Are any of the steps in that problem hard? No, actually. They are actually very easy, simple steps, dividing. And what you're going to find is we're not dividing big things. Up here we were simplifying it. We were just doing 27 divided by 23 instead of the whole 2,000. We're breaking it down into smaller parts. So this is the breaking down of a long division problem. So let's see how that works with polynomials. As I said, steps are going to be the same. These are going to be the exact same steps, whether I'm talking about a multi-digit number or a multi-term polynomial. So let's take a look and see how this works out when we are dealing with a polynomial. We want to take the polynomial 3x to the 4th minus 5x cubed plus 2x squared plus 3x minus 5. And we're going to divide that by 3x minus 2. In order for me to do that, I need to use long division. So I'm going to do these steps. The first step was to divide. Now, in the case of a multi-digit number, we just divided the first couple of digits. For a polynomial, we're going to do the first term. So I'm basically ignoring the rest of the polynomial for the moment. And I'm just going to divide the first term. So I need to take 3x to the fourth and divide it by 3x. So 3x to the fourth divided by 3x. It looks like the 3's cancel out. And x to the fourth divided by x. 4 minus 1 is 3. So that's going to be x cubed. So divide the first terms, and just like when we were doing numbers, I'm going to write it up top. My second step is to multiply. But I see this warning here of don't forget to distribute. This is a binomial. So in order for me to say x cubed, I am going to have to distribute it to both of them. So x cubed times 3x is going to be 3x to the fourth. And x cubed times negative 2 is going to be negative 2x cubed. So that is my multiply step. Third step says to subtract all terms being the key phrase here. I need to subtract. I'm going to subtract 3x to the fourth. But what's minus a negative? And this is where most people mess up. They forget to go down and subtract all of them. Minus a negative becomes plus a positive. So that when I subtract these, notice the first terms cancel out. Folks, the long division is designed so that those first terms will always cancel out. If those two don't cancel out, you didn't do it right. That's a warning sign. These should always cancel out. These might not. So negative 5x cubed and positive 2x cubed is going to leave me with negative 3x cubed. And now I'm down to my last step, which is to carry down. So I need to carry down plus 2x squared down here and start over. It says to repeat. So I'm going to come here and I'm going to take my first term and I'm going to divide it by my first term. So negative 3x cubed divided by 3x. So negative 3x cubed divided by 3x. The 3's cancel and it leaves me with negative 1. X cubed divided by x is x squared. So I get negative 1x squared. Do you have to write the 1? No, you can just put minus x squared. That's perfectly fine. I'm now on the multiply step. I'm going to distribute. So negative 1x squared times 3x is negative 3x cubed. Negative 1x squared times negative 2 is positive 2x squared. When I get to my subtracting step, minus a negative is plus a positive. Minus a positive is a negative. So those will cancel out. 2x squared minus 2x squared does actually cancel out as well. So that was a nice little treat. Now we're at the carry down step. So I'm going to carry down a positive 3x. And it looks like since these canceled out, I probably need to go ahead and carry down the second one as well. That was a double bonus. That just means I have one less step to go. That's pretty awesome. So let's repeat, because again, you keep repeating till you run out of things to carry down. So we're going to just keep on trucking. So next up is divide the first terms. So here's my first term. 3x divided by 3x. That one I think I can even do in my head. 3x divided by 3x is just 1. So it's going to be positive 1. 3x times 1 is 3x. And 1 times negative 2 is negative 2. When I subtract, I get minus, and minus a negative is plus a positive. 3x and negative 3x cancel. Negative 5 and 2 is negative 3. I'm at the carry down step, but there's nothing to carry down. And we said that meant we were done and that this was our remainder. But just like back here, when we had the number, we have to write our remainder as a fraction. So my remainder happens to be negative 3. So I'm going to do plus negative 3 over the divisor. Folks, it doesn't matter if that divisor is a polynomial, a binomial, a monomial, or a number. You put the remainder over the divisor. So that means that 3x to the fourth minus 5x cubed plus 2x squared plus 3x minus 5 divided by 3x minus 2 is equal to x cubed minus 1x squared plus 1 plus negative 3 over 3x minus 2.